Okay, so we're looking just at perpendicular vectors, so that makes it a lot easier. You probably have already guessed kind of the basic process on this, but let's talk about the process. So even though we're not doing this graphically, you still want to sketch out the vectors. And in doing so, right now we're not going to draw them so much to scale. So you don't necessarily have to have a ruler and protractor sketch them out. Just sketch them out. I would still try to draw, if it's one's twice as long, the other try to draw it twice as long. So sketch the vectors. And then you also want to go ahead and label them. Very important to do that. Label the magnitude, and direction. And again, as you sketch them, since we're adding them, make sure you still sketch them tip to tail. And of course, then you want to tip to tail, you're going to draw the resultant, that answer. Remember that the resultant is a vector. So it has a beginning and an end, and you should have an arrow on the end. So we know which direction it's pointing, which direction it's going. On end. And then we're going to use the Pythagorean theorem and then trig to find the magnitude and direction of the resultant. Alright, so Pythagorean theorem and trig to find the magnitude and direction of the resultant. So we've done these pieces already, now I'm just going to put them all together. So let's run through a couple examples. And just with perpendicular vectors today, so that means everything will be essentially a right triangle, makes it much easier. Okay, first one, I want to add 25 miles north to 50 miles east. Okay, so I'm going to start by drawing the vectors tip to tail. And again, I probably want to, the north one's only 25, the east one's twice as long. So probably, try to draw it. So here's my north, and this is 25 miles, always label it. And I'm going 50 to the east. Okay, so then we need to draw the resultant from beginning to end. So here's the resultant. Call that maybe R. Vector R. Okay, so how do I find the magnitude, the length of this? We know that for a right triangle, right, a squared plus b squared is c squared. My hypotenuse is the sum of the length squared. So that means c, of course, is the square root of a squared plus b squared. So it's the square root of 25 squared plus 50 squared. So, unlike in math, where you may always keep it exact, we'll always approximate that in physics because it's an actual number we're going to work with. So the square root of 25 squared plus 50 squared, 50.9. I wasn't very careful with significant figures. We're just going to call it 50.9 for now. 55.9, yes. 55.9, and it is what units? Miles. So 55.9 miles. Remember that the resultant is a vector, so that's not enough. I can't have just a magnitude, I also need a direction. And so I always had this question came up a lot, where do I measure the direction from? Always at the base of the vector, right? And always from an angle I know. I know that this is straight north. So I need to measure this angle here. Let's call that theta. So how can I find theta? So what trig function do we call the opposite of the adjacent? It'll be a tangent, right? In other words, the tangent of theta is 50 miles over 25 miles. Which in fact is equal to what? Just 2, right? Of course, these are ratios, the units always cancel out. So theta, I mean to find theta, I have to use the inverse tangent function of 2 in this case. Now, usually it come out to be such a nice number. This time it did. So the inverse tangent 2. And that would be 63 degrees. That's still not enough, is it? I need to know where that 63 degrees is. So where is it? It would be, we're rotating that far from north. I should put my arrow the other way, shouldn't I? We're rotated to the east, right? So that is east of north. And now that describes that vector perfectly. I know exactly how long it is, this magnitude. I know exactly where it's at. Okay? Alright, let's try one more. Number 2. Add 75 kilometers south to 21 kilometers west. Also, remember the order does not matter that you add vectors, and you can add them in any order. So you could start this west one or you could start the south one, it doesn't matter. We start with the south, we've got 75 south. Make sure you always draw these tip to tail. So don't ever put the other one, the next one, up on the tail of this one, or it's the tip. Then I'm 21 to the west. Always label. Okay, so this is my resultant. We know that since this is south and this is west, this has to be a right angle. So how do I find what R is? Right, be the square root of the hypotenuse. Once again, I wasn't very careful. I guess we go 2 significant digits on this one. 78 kilometers. And then what angle do I want? This one or this one? At the base, right? So how many degrees have I rotated to the west from south? So that means that tangent, called theta, the tangent of theta would equal what? Or theta is the inverse tangent so I'm going to say the inverse tangent of 21 divided by 75. So 15.6 degrees to 16 degrees, where? Yeah, west of south. Of course, I could also have the complement of that, right? I mean, we know then that if this angle here is 16, this angle here is what, 74? So we also could have 74 degrees south of west. And in fact, in all these, there would be 2 possible answers. Okay. Questions? Okay, in your book, on page 89, complete 1 through 4.